we're continuing with looking at integral calculus, and now we've learned enough of the basic skills to start applying them. So the key concepts is that an integral measures the area under or between two functions, and I'll just quickly show you this. If you've got the area between two functions and the, oops, I want to, so let's call this function f of x, and this function g of x, and we want the area between f of x and g of x. We want this area here. Then if we added k to the functions, do you know, if we added a number k, do you understand that that would shift the functions up in the vertical direction? So just give me a tick. Do you understand that I could move both g of x and f of x up so that they were all, the area we talked about was all positive? So when you read your weekly work, they explain that in a lot of detail, but I'm saying please check that out and make sure you understand it. But what it means is that when you do f of x, take g of x, because f of x is the function on top, take g of x, the function below, the add k, take k would disappear. That moved it up so that you prove to yourself that the area is positive. So that's the first concept. The next is that you're going to do the area from the lowest value here. Now I can write the letter A even though A is going to be a negative number, so I'm just using A as the lower number and B as the higher number. So quite often before you can find the integral, the definite integral, you have to determine using intersection of functions A and B. Now you can do that on your calculator most of the time unless you're asked for an exact value. So we're going to do the definite integral from A to B from the top function. So even though f of x ends up underneath, the area we are interested in, f of x is the higher function. So it's going to be the higher function take the lower function. And we're going to integrate with respect to x. Pete, it's good to have you here. That's good. Now, Hannah last week sent me an email saying the weekly work questions left out E.2, I believe, which was practicing finding the constant of integration. So I'd like you people to get out a bit of paper. I want you to do this question and I'll just quietly write the solution on the screen. So give me a tick when you've finished this question. Yes, Pete? All right, let's see if I've made a mistake. So, okay. Well, actually, as I look at my work, I'm meant to be putting in 0 for x. 0 to any power. Actually, I'm not. Yes, and that's something else I should have pointed out because that's we use that very rarely. All right, so that was a very interesting question that drew on some knowledge to complete it. All right, so I've talked this through at the very start of the lesson, Reese. But I didn't talk through working out the area between two trig functions. So, could you just quietly read this information, and then I can give you permissions, and then make any comments or any questions, things that you need to know. So have a quiet read. That's right. So, and as you see written here, the vertical distance, they call it a translation because it shifts vertically. All right, so in stage one, I believe that you looked at the shape of your trig functions and you looked at those attributes. Can I have a tick, even if you don't remember it very well, can I have a tick if you say, yes, I sort of touched on it? So I think it's chapter one. Here it is. In chapter one, you might find it's worthwhile to go back and just do, on your graphics calculator, just draw some of these functions and take the time to notice what the different aspects do. So that's assumed knowledge. Now, this instruction is to show you that you can show the area of integration on your calculator in the graphing part of your calculator, depending on what calculator you have. So, if I just get you to have a look at your handheld graphics calculator, because what you'll find is the emulator does, everyone's has slightly different skills, and I'll just quickly say this. I've got a very nice, very recent Casio, and I can go into the graphing menu, I can go into more choices, and I'll see the integral symbol. I click on the integral symbol and I just press the blue execute, like it'll go to an appropriate point, which is often 0. If I want 0, I press execute, and then it says upper limit, and I type in the upper limit and I press execute, and it immediately draws. It's very, very nice. But the emulator is not quite so nice. My old calculator is not so nice. And to get exact values with the older calculators, I'm best off going to the run menu and pressing the option button and finding the integral symbol under calculation. Can I have a tick? Is that quick general information sufficient for you to play around with your calculator? With calculators, and I know that some of you don't have Casio, with calculators you've got to take the time to know how your own operates. And Hannah has actually got a more up-to-date calculator from Open Access. So if you own or your school has loaned you a graphics calculator and you find that it's getting pretty old, we will loan you one. And so if you're going to make that decision, make it early in the year so that you get used to what you're going to use in the external exam. Okay, let's have a look at question 1. How would you go about finding the shaded area using geometry? Hannah, there was talking in the background and I think it was blokes. I didn't really pay much attention. So I have given you permissions. I'll just double check because sometimes when I click on the permissions, yeah, they're working. So communications to all participants is nice. All right, so I can see some yellow lines. Does someone who's drawn the yellow lines want to explain what you're doing? Oh, excellent, Pete. Can anyone help? All right. So, people, do you agree that without a grid behind, you've got to guess that at 1, the point is 4. So we're guessing that that point there is 1, 4. But what Pete has just said, when x equals 1, if you put 1 into the function, so f of 1, so if you put 1 into the function y equals 4x, then 1 times 4 is 4, and we do get the 0.14. I want us, can I have a tick? Do you understand that putting the x value into the function gives you the y value? Have a little think. All right, superb. Because again, once you understand that, you sort of say, of course. But the point of noticing it can often be, oh, right, that makes sense. So for the other point, let's just quietly check. When x is 2, the notation is the y value is the function value at 2. So you've got to get accustomed to that function notation. And so then when we put 2 in, 4 times 2 is 8. And looking at that yellow line, yes, it did come out at 8. All right, someone other than Pete. Once you've identified some key points on that shape, does anyone want to explain what they do, how they could work out the area? Callum, can you share with the class what your thoughts are? How can you work out the area using geometry? Thank you, Callum. That's certainly true. Can anyone think of a second method? So Callum's method and the blue drawing definitely works. Can anyone think of another geometric shape? Yes, Hannah? Exactly. And you may remember a trapezium has a pair of parallel sides. So this does. And the area of the trapezium is the average of the parallel sides. So what it's doing, the formula is actually making an average. Now I haven't drawn it in exactly the right spot. So what you do is you'd have the height here, which we worked out was 8, plus the height here, which is 4. 8 plus 4 divided by 2 will give an average of 6 times by the width, and 1 take 2 is the width, and so it will be 6 units squared using geometry. So splitting it into little pieces definitely works, but if you notice that it's a recognised geometric shape with a formula, the bigger the shape, the less number of calculations. All right, can you quietly check uh, um, the calculation using integration? So I will also just write the solution on the screen. So I'm just repeating myself. In a conjecture, quite often the geometry is really important, and knowing the shape and key features on the shape is really important. So, thank you. We're going to get you to draw the function either x and the function ln x on the same set of axes. Oops. Your name is? Thank you. So, can you please add key points on those graphs? So I'm very, very pleased to see labeling. The graph top right has a scale, but the key axis intercepts have not been marked on, and I recommend that you put that value in. I nearly guessed Hannah, but I didn't want to get it wrong. Brett's in, which is wonderful. Welcome, Brett. Great to have you here. So, Brett, what we're doing, I have been taping the lesson so I can send it to you, but just a very quick summary. When we apply our knowledge of integration, often integration involves, well, it measures an area between two functions, and that area has meaning. So we often use motion. So if the function that we integrate is a velocity function, it takes us backwards to displacement. And so the area would be measuring the amount of displacement. If it was a concentration function, then we might integrate the concentration function and go backwards, and we might be able to work out the amount of time a reaction has occurred or the temperature. So it can take us back a step. And the other thing that I've mentioned was that quite often we can make a generalization from the pattern of a formula. And conjecture is something you need to do on any topic, but integration lends itself to conjecture. So there's some conjectures up in the Moodle that I highly recommend you have a practice. By next week, there's still 2 weeks of new theory to learn, but by next week I'm hoping to put up the practice test because Wednesday in week 10 is the integration test. So if you've got just a little bit behind on your weekly work, push to catch up, because as soon as the theory finishes, you're going to have about 4 days before you need to do a test on it. So I now see much more detail, and the bottom right corner is very symmetrical. So I know it is very, very hard to draw on the WebEx, but the bottom right graph, can you add the line of symmetry? What is the line? Do you know the line of symmetry between the function y equals e to the power x and ln x? Oh, does anyone have any idea what the line of symmetry is? Yes, that top right drawing is also very neatly done. Can you see that when x is 1, y is 1? So y equals x is the line of symmetry. So what I see you've written in, you've I hope you're aware that the function y equals e to the x or e to the t, whatever you've used, is always above the x-axis. So for every value of x, the function is positive. So even here where x is -10, the function is just above the x-axis. E to the x is always greater than 0. So if you're asked if your function is positive, well, e to the x is always positive. That's something to notice. People have marked in the intercepts so that if you had the function, if you were working out ln x and you happen to be told that x equals 1, well, then you would know that ln of 1 is 0. All right? So you'll be able to picture that. So some of these key bits of information become very important, or background assumed knowledge when you're working on conjectures. And always, it is best if that knowledge is secure, that you don't have to use your graphics calculator to do the sketch. But under pressure, if you forget, remember you can draw these functions on your calculator. So if you're going to find the area bounded by these functions, then if you already know that e to the x looks like this, passing through the point 1, and notice how the function goes on forever, so it has arrows on the end, and also the x and the y-axis go on forever. When you draw a sketch, you need to show those basic bits of information, and you need a scale. So the fact that I've put a 1 there is just sufficient, but I do recommend that you do have a basic scale showing. So we know what y to the e to the x looks like. The x-axis is y equals 0, and the y-axis is x equals 0. So whatever colour you like, and the line x equals 1. So it doesn't matter what value x is, the y coordinate is always 1. Can you mark on this graph the area that's being referred to? I've got it wrong. I've done y equals 1. Let's try that again. Yes, thank you. So can you shade in the area that is being referred to? Excellent. Now, on your own piece of paper, can you write an integral expression for that area? Just give me a tick when you're finished. Okay, I'm glad you noticed that, Hannah. I've begun to emphasize that the area is between two functions. And what we've been doing is we've been integrating the top function with respect to the x-axis. The equation of the x-axis is y equals 0. So if we're going to write the top function minus the bottom function, which is what we do in general, well, actually we're taking 0, and that's why we don't normally bother to put the 0 there. So I'm really pleased that you asked that question. So just a tick from everyone if you have been able to write down that expression. So when you integrate the function e to the x, you have the function e to the x. So you've integrated it. To show you've already integrated it, but you haven't put in the values yet, we just have a line on the end to show, all right, we've done the integrating, and now we're going to do the definite integral. So e to the 1 subtract e to the 0. E to the 1 is just the value e. What is e to the 0? Yes, it is. Many people put 0 down. Don't you do that. Anything to the power 0 is 1. So if they ask for an exact answer, you would leave it, because e is an irrational number, 2.71 something or other, okay? But you'd leave it as that number. Or if they said to 2 decimal places, can you quickly find e on your calculator? And the reason I'm asking you to do this is that it'll have e to the power. You must put e to the power 1 to get the value of e on your calculator. So just have a practice at that. And to get out of the power, you've got to hit your navigator pad to the right. And if you were asked for 2 decimal places, that's right, Pete. And the only thing wrong with Pete's answer is he hasn't written the subject, the area equals. So if you guys are going to type up your answers, could you put A equals? And I'm really pleased to see the units there. I'm not going to ask you to create your own question because the time's getting away from us, but creating your own question actually is a very good learning technique, because it makes you say, what information do I need? How am I going to present that information? All right, so I'd like you to do this problem, please, and give me a tick when you're done. So I just want to remind you that on your graphics calculator, if you want to draw y equals sine 2x, type it in, which I'm just slowly doing. And then when you go to draw it, just check your view window. Shift view window. And down the bottom, you'll see above function 2 is trig. So instead of having the initial window, have the trig so that it's using radians. And I want my minimum to be 0 radians, and my maximum I want to be 2 pi radians. Oh, and I think my calculator must, it's not working. Shift. Setup. I'm just changing my setup. I want my angle to be in radians. So I got a flat line initially, and I had to change my setup to make sure it was reading in radians. And so a complete cycle is pi, which is 3.14 radians. And half a cycle is pi on 2. So that's what we were doing at the start of the lesson, realizing that sine of 2x is going to change the period. It's actually going to shorten it so that a complete cycle occurs in pi instead of occurring in 2 pi. And so the area enclosed by one arch means from 0 to pi on 2. So just give me a tick. Do you follow that there's a lot of background information in setting up the question, and doing a sketch or drawing a sketch on your graphics calculator is a really important part. So once you've done that, you can actually put in, we want the integral from 0 to pi on 2, that's exact. All right, and you can do that on your calculator, of the function sine 2x with respect to x. And depending on what calculator you have, you can either do it through the graph menu and do the integral, but the medium age calculators, I find to get the exact value, I go to the run menu and do the option. Choose the option button and find calculation and find the integral symbol. Okay. So, I can't remember why I set this question. Let me go ahead. All right, we have time to do this, so let's do this question. All right, I'm just going to ask, how did people start this question? Could you share with other class members, what have you done first? Reese, can I ask you, what have you done at this stage, if anything? I've got silence, Reese. Does that mean that you're you're concentrating? Okay, so Pete's calculated the area. Pete, what did you do first? Ah, fine, no worries. Yes. What have you done first, Pete? Okay. And so you're going to draw the function x cubed plus 2x squared minus 3x? Sketch. Yeah, sketch it. All right. So even if you might put it on the calculator, but y equals x cubed is like that, sort of. Once you've got the 2x squared minus 3x, sometimes it's sort of like this, okay? So this is an absolute sketch, all right, not based in reality at all. But that's the sort of thing that you might have in your mind's eye, all right? So at this stage, there doesn't seem to be any need to have a really detailed picture. So let's go ahead. You may have done this already and integrate. Well, what is the next thought? Is there another, as you go to integrate, is there a next thought? Hannah, the fact you've graphed it, what has that helped you to find out? Not much. All right. Can you find the roots? And when I look at that equation, I can see that x is a common factor. And so I know that one of them is going to be 0, 0. So I already know my sketches are off. So I'll give you people a bit of time. Draw the sketch, then just do Shift G solve and find the roots, which is where it cuts the x-axis. All right, so there's a third root, Hannah. Do you want to say what it is? Excellent. So now we can do an improved sketch. So now it goes through 0, 0. I don't have a scale, 2, 4, 6. So minus 3 is approximately here. And positive 1 is approximately here. So, all right, my scale is pretty small. But what it means is if I'm going to work out the area, I need to be aware that that bit's positive, that bit's negative. All right, so you can do the integral of x squared, x cubed, plus 2x squared minus 3x with respect to x. And that will give you the total area where this area is positive and it will take away this second area, which is negative. So the answer will be less than the integral from minus 3 to 0 of our function will be a larger number than the integral from, will be a positive number, and the integral from 0 to 1 should be a negative number. So I'm just doing a calculation, integral. I'm going to do the overall calculation. Can Brett and Callum, I'll put your letters up there, Brett and Callum and Hannah, could you do the integral from minus 3 to 0? And Pete and Reese, could you do the integral from 0 to 1? And I'm going to do the overall integral. And actually, once you've done one integral, you can actually reuse your integral and just do the others. And I'll just write what I get, and you just check. You might put a tick if you agree. Yep, so that's good. I've left minus fractions. So what I want you to be aware of is if you put the integral into your calculator, it will add the areas vectorially, if you like. So it's working out, so this area is above the x-axis, so the integral will be a positive area. Area 2 is below the x-axis, so it will give a negative area. So there's a bit of a language with calculating areas. So I could say area 2 equals 7/12. All right, if I wrote area 2 equals 7/12, and I asked you from my diagram, what is the integral from 0 to 1? You would have to say area 2 is below the x-axis, therefore it's a negative integral. Great. So I'll leave it there. I have another lesson that should already have started. Let's put